introduce myself. My name is Tom Slawski. My real job is to work for the Southeastern Wisconsin Regional Planning Commission, not to organize this event, but this is a fun thing that we get to do as part of this. And I'm going to talk about this effort that we've been working on for the past several years. As soon as we get it up, it's an issue that's come up that it began with my commission is run by 21 commissioners, and it was at their urging that this whole effort to look at chlorides and salting practices and basically challenged our environmental division, both Laura, myself, and several other staff members have now moved on to work to get the funding and to basically, in a nutshell, try to get a handle on how bad is the problem. And by chlorides, I mean, we should have called it the salting study. So we're talking about sodium chloride. And but basically, how bad is it? And where is it coming from? And what can we do about it? And in a nutshell, that began in more than a decade ago. We are finally in a position where we're finally getting all our technical reports done. And I'm giving you the Cliff Notes of the Cliff Notes version today. And there is a lot more documentation on our website with all the technical reports coming out. And before I forget, we are working on our final planning report with recommendations. And it would not be possible without, collaboration and partnership with DNR and of course the federal folks and MSD as well. And why are we interested in chloride or in salt is because it's basically a forever chemical, and once it's dissolved in water, it's extremely difficult to get rid of it. And there are many communities, ours alone, with I've noticed rising levels in a lot of our waterways, and so this was an integrated approach to try and figure out what's going on. All right, buttons are working. So how bad is it? Moving on, this is just the stream sites, and you can see a color of rainbows there. So we're seeing everything between less than 35 milligrams per liter, all the way up to over 2,400 milligrams per liter of salt. And they're speckled all around the region. And you can see the distribution is wide and wide ranging. And so it's a bit of good news, bad news. Some areas are quite bad. Other areas are not so bad. So that's a start. However, we have a lot of impairments, both acute and chronic. And the state of Wisconsin is a 395 threshold, and the acute standard is 757. And there are other EPA standards. I can talk more about that in a minute. But there are a number of sites that are impaired. So again, it's a problem. And we were able to look at we had some real-time monitoring, and it's not as just so much the threshold. This is a really good example. This happens to be on Lincoln Creek. Within over a 2-day period, chloride levels went from 40 milligrams per liter to 4,000 milligrams per liter. So you can see in the pink there was a freezing rain event. So interesting, you see a dip. There's like a dilution of chloride concentrations in the river. And then, of course, there must have been some de-icing that occurred. It jumped up, and then more snow, and we applied, and it jumped up again, more snow, and we get that impulse. And so the speed with which the streams can respond was also a very big surprise and quite shocking. So to put this in perspective, seawater is about 19,400 milligrams per liter chloride. So of course we're nowhere near that. And but we're well within the brackish range of 500 to 5,000 milligrams per liter. So that gives you some sense of the level of contamination. And I'm just going to say 80% of our streams, chlorides are increasing. There's a lot more nuance than that, but that trend is clear. But what's more important is that the driver to all of this is land use. And you heard Jacob talking about it, that impervious surface, the more pavement, more application area for salt. And so it's tightly correlated to roads and parking lots and land use, not so much ag. So this sets up a mosaic. That's why you see colors all over the place throughout the regional area. And that's because the driver is tied to land use. And we did figure out where it's coming from. So at least with the 7 counties in Southeast Wisconsin as part of this study. And I was watching the Olympics, and so I was inspired by the awards ceremony. So who's going to guess? In third place, the winner goes to agriculture, right? 5% load. Second place, wastewater, correct. I heard the answer, 36% of the load. And finally, top of the podium, right? De-icing of 58%. And we got to give one little honorable mention to atmospheric deposition at less than 0.5%. So it gives you a context of kind of the composite. Now, this is the general load for the whole region. And of course, not everyone's got a wastewater treatment right on their stream. And ag is more or less. So these loads do change, you know, with areas and throughout the watershed that kind of set up with the mosaic. But this gives you the general load overall. And de-icing, FYI, can comprise 50 to 99% of the load. So it's bad. And this is consistent what we know with our salt usage and our salt use for de-icing. We've been ramping up, particularly since the 60s, and continues to increase. Moving to our lakes, not surprising. This looks almost just like the salting application, right? So thank goodness all our different data sources are all making sense, you know, from very disparate areas in the landscape. So there's a lot of things I want to talk about here. One, lakes, all you can see emanate from this one background concentration, which is less than 10. So that's consistent. And you can see that it's bad. We're all progressing. Not all bad, because we've got Lake Wandawega is still less than 10. We talked about Geneva earlier. That's trucking in the middle. And our worst lake, Little Muskego. It gives you a range and size of the different thresholds there. And but they're, for the most part, the majority are all increasing just like the streams. And nowhere are there higher concentrations than now. So yesterday is not the same as today. And again, I just want to talk briefly about thresholds, and that she's counting me down and I'm running out of time. But we, in our reports, we established a number of thresholds that are helpful. The background is 10, and we instituted what we call a minimum 35 milligram per liter lower conservative impact threshold. And there are some other thresholds from Canada and the US EPA, and Wisconsin thresholds are there. And then the extreme, call that our extreme impact level. And I bring this up because bottom line, our research shows that Wisconsin's thresholds and the national thresholds, they're just not protective enough, bottom line. And so that's why we incorporated this range, particularly 35 to 120, because there are so many community level, system level impacts and sublethal impacts associated with it. You know, loss of sensitive species, loss of diversity, loss of zooplankton, reductions in fish diversity, egg mass changes, developmental delays, deformities. So these are all subtle things. Some of them are very difficult. Some are even behavioral. Frogs won't even they just, maybe you don't hear frogs anymore, right? In your local ponds. Well, there could be a real reason for that. They won't spawn if the concentrations get high enough, or reproduce. They don't spawn, sorry. They won't lay their egg masses or congregate there. So with that, that's an important thing to remember. But in terms of the lakes, same as the streams, it's land use is key. Roads and parking lots, and percent urban land use at the watershed scale. But also, we also found for lakes at the shoreline zoning scale as well. So that boundary of 1,000 foot around a lake is just as important in determining how much concentration of chloride you have in your waterway as it is in the entire watershed. This is something maybe we can take advantage of, and maybe, DPWs can also maybe tailor their salting management practices around particularly sensitive water bodies like lakes. No other driver was as important as land use. That's just it. And so economic development, strong economy is great, except the consequences of all that urban development, right? And roads and parking lots, the downside is we got to deal with that, is that with it comes potential increase. Even if you don't increase your rate of application rate, you just have more roads. You have higher load. So that's what's going to happen. And the bad news is, now we didn't see this in our study. These trends that are increasing, those are just a few of the worst lakes, just to see real time. Two things. One, in lakes, it's very obvious, unlike the streams that go up and down, lakes, they just keep going, right? So it keeps increasing. And so it's not, we're like brining our lakes, and so they're not coming down. And that's most likely influence of the groundwater that we're also impacting. We'll talk about that in a minute. But when lakes get bad enough, this is happening in Madison, it's happening in Canada on some lakes. This salting can lead to interruption of the mixing, can lead to deoxygenation and remobilization of phosphorus. So basically, it can undo all of the phosphorus loading things that we've been doing for the past 30, 40 years, right? So this is unintended consequences of this, and it can have profound impacts on harmful algal blooms and all these other. So that's why it's so important. So recently, Madison, their drinking water had a quarter of their wells are no longer meeting sodium concentrations, and it's well known that parts of their groundwater systems and aquifers contaminated with salt, de-icing salts particularly. So the high sodium levels, given that another statistic, number one cause of death in Wisconsinites is heart disease, right? So high, not beer drinking, no. Not too much cheese either, but no, I was surprised. I was surprised myself. But increased sodium increases risk for hypertension and disease, heart disease, and stroke. So it's a serious enough human health issue that they're warning people within their wells. So this is a big deal. So now we're getting into human health impacts. So how's that looking for Southeast Wisconsin? Here are some municipal wells, and well depths on the bottom and concentrations are on the side there. So our shallowest wells are our highest levels of contamination of chloride. So and that's because, right, the connection is closer to the surface water, and we're getting infiltration, and it's being exhibited in that groundwater. That's not good. In addition, same thing is kind of happening. You look at time series, just like the lakes, the municipal wells, also the shallowest wells on top have the highest concentrations. They're increasing at the fastest rates, and they're higher overall in chloride. So, and these are also associated with increased sodium concentrations as well. So we're seeing the same things that Madison's seeing. If we have more people, so these are elevated in comparison to that. So what does that mean? Here we are. Driver safety, walking safety versus water quality, aquatic ecosystem, and drinking water supply and human health. It doesn't get any more challenging than this, right? And I don't think anyone wants to be living here if we can't drink the water. So these are things that are upon us now, and there are things we can do, and not every area is the same, which thank God. But we can all do more. I don't need to get in too much about what we can do on our own property, but you know, I sweep up my salt when I over apply. I don't apply to my south basin driveway, but I got this spot on the north side. I got 10% slope on my mother-in-law's coming over. I'm gonna throw some salt down. I'm not gonna fall down on my job. You know, I got to keep that open. So I get it. We gotta keep safe, but still, there are things, you know, water softening equipment as well. Salt wise, you got to give them a plug. They got amazing amount of resources, and they've been here last year, the year before, and we'll probably bring them back. Also, I really want to talk about what can your community do. Districts can play a role. Okay, I'm getting there. But it's an educational campaign and a challenge. Municipalities, they're doing some great things. Brining, pre-wetting, you know, salt's expensive as well. Calibrating trucks. Yeah. I do know
Free strips you can get from Isaac Walton League.
There are free strips you can get from the Isaac Walton League. I wanted to mention that in the city of Madison, they decommissioned or removed 50 miles of road from their salting routes. So maybe that's part of the solution. And water softener removal and upgrades as well. But it needs to be also, monitoring is a big deal, helping to know where you're at. And then state agencies are doing some really good things. Research, cutting edge technologies, these are all important parts. There are some folks in communities adopting resolutions and applying incentivizing best management practices. Those are all important points. But I wanted to get to these. These are the biggest, I guess, nuts to crack. The legislation to reduce slip and fall liability from businesses, without addressing that, I think many of these issues in parking lots will never get solved. And so that combined with a smart salting certification, very important. And all of these other things we've identified in many of our technical reports and things, you know, the standards are high enough. We certainly could try to enhance greater levels of salt concentration levels to try to achieve, but that's probably not focus of the best of our efforts, right? So more carrots, more funding opportunities, and more ways to facilitate action is going to be better than anything else right now. And the communities are all doing some great things, and we can learn from the rest. And that's I'll have to quit. So with that, the next speaker.